everyone, and welcome back to the channel. I'm so happy to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment, and for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I'm here to help you succeed. Today we are going to continue our journey into coordinate geometry. This is part 2, and we are going to talk about the circle. This lesson is suitable for SHS 1 and SHS 2 students. Now, I know that when you hear the words coordinate geometry or circle, you might feel a little nervous. Many students find this topic challenging because there are many formulas and rules to remember, but I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes, so we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to define a circle as a locus of points. You will learn how to derive and use the standard equation of a circle. You will learn how to convert between standard form and general form. You will learn how to determine the center and radius from any given equation. You will learn how to determine the position of a line relative to a circle, whether it intersects, is tangent, or has no intersection, using the discriminant. You will learn how to find the equation of a tangent to a circle at a given point. And finally, you will learn how to solve problems involving chords and properties of circles. That is a lot, but we will take it one piece at a time. Let us start with section 2, Introduction to the Circle. First, what is a circle? A circle is the locus, or path, of all points in a plane that are at a fixed distance from a fixed point. This fixed distance is called the radius. This fixed point is called the center. Imagine you have a pin in the center of a paper. You tie a string to it. You put a pencil in the loop of the string. You keep the string tight and draw around the pin. The path your pencil makes is a circle. The pin is the center. The length of the string is the radius. Now let us look at the derivation of the equation. Let the center be C open bracket a comma B close bracket. Let any point on the circle be P open bracket X comma Y close bracket. The distance between C and P is equal to the radius R. We know the distance formula from our previous lesson. It is the square root of open bracket X 2 minus X1 close bracket squared plus open bracket Y2 minus Y1 close bracket squared close bracket. So the distance CP equals the square root of open bracket X minus a close bracket squared plus open bracket Y minus B close bracket squared close bracket. And we know this distance equals R. So square root of open bracket X minus a close bracket squared plus open bracket Y minus B close bracket squared close bracket equals R. To remove the square root, we square both sides. This gives us the standard equation. Open bracket X minus a close bracket squared plus open bracket Y minus B close bracket squared equals R squared. Please write this equation down. It is the most important formula for this lesson. Now, let us move to section 3. Standard form of a circle. The equation is open bracket X minus a close bracket squared plus open bracket Y minus B close bracket squared equals R squared. Here, open bracket a comma B close bracket are the coordinates of the center, and r is the radius. Remember, the radius must be greater than 0. There is a special case. If the center is at the origin, which is 0, 0, then a is 0 and b is 0. The equation becomes x squared plus y squared equals r squared. This is a very common form you will see. Let us look at example 1. Finding center and radius. Find the center and radius of the circle open bracket x minus 3 close bracket squared plus open bracket y plus 2 close bracket squared equals 25. Step 1. Compare with standard form. The standard form is open bracket x minus a close bracket squared plus open bracket y minus b close bracket squared equals r squared. Look at the x part. Open bracket x minus 3 close bracket squared. This matches open bracket x minus 8 close bracket squared. So a equals 3. Look at the y part. Open bracket y plus 2 close bracket squared. This looks different, but remember, plus 2 is the same as minus negative 2. So it matches open bracket y minus b close bracket squared, where b is negative 2. Look at the right side, 25. This matches r squared. So r squared equals 25. To find r, we take the square root. The square root of 25 is 5. Answer: center is open bracket 3, comma negative 2 close bracket. Radius is 5 units. I want to give you a warning. Be careful with signs. If you see open bracket x minus 3 close bracket, the center x is positive 3. If you see open bracket y plus 2 close bracket, the center y is negative 2. The sign inside the bracket is opposite to the coordinate. Please remember this well. Let us look at example 2. Finding the equation. Find the equation of a circle with center open bracket negative 1 comma 4 close bracket and radius 3. Step 1. Identify a, b, and r. A is negative 1, b is 4, r is 3. Step 2. Substitute into standard form. The form is open bracket x minus a close bracket squared plus open bracket y minus b close bracket squared equals r squared. Substitute a. X minus open bracket negative 1 close bracket. This becomes x plus 1. Substitute b. Y minus 4. Substitute r squared is 3 squared, which is 9. So the equation is open bracket x plus 1 close bracket squared plus open bracket y minus 4 close bracket squared equals 9. Answer: open bracket x plus 1 close bracket squared plus open bracket y minus 4 close bracket squared equals 9. This was straightforward substitution. Just watch the signs again. Now let us move to section 4. General form of a circle. Sometimes the equation is not in the nice bracket form. It is expanded. By expanding the standard form, we get the general form. The equation is x squared plus y squared plus 2gx plus 2f y plus c equals 0. Here, g, f, and c are just constants. How do we find the center and radius from this general form? For the equation x squared plus y squared plus 2gx plus 2f y plus c equals 0. The center is open bracket negative g, comma, negative f, close bracket. The radius is the square root of open bracket g squared plus f squared minus c, close bracket. There is a condition for a circle. For a real circle, the radius must be positive. So g squared plus f squared minus c must be greater than 0. If it is negative, there is no circle. Let us look at example 3. General to standard. Find the center and radius of x squared plus y squared minus 6x plus 4y minus 12 equals 0. We will use method A first. This is using formulas. Compare x squared plus y squared minus 6x plus 4y minus 12 equals 0 with x squared plus y squared plus 2gx plus 2f plus c equals 0. Look at the x term. 2gx equals minus 6x So 2g equals minus 6. Divide by 2, g equals negative 3. Look at the y term. 2y equals plus 4y. So 2f equals 4. Divide by 2, f equals 2. Look at the constant. C equals minus 12. Now find the center. Center is open bracket negative g, comma negative f, close bracket. Negative g is negative of negative 3, which is positive 3. Negative f is negative of 2, which is negative 2. So center is open bracket 3, comma negative 2, close bracket. Now, find the radius. Radius equals square root of open bracket g squared plus f squared minus c, close bracket. G squared is negative 3 squared, which is 9. F squared is 2 squared, which is 4. Minus c is minus open bracket negative 12 close bracket, which is plus 12. So inside the root, we have 9 plus 4 plus 12. 9 plus 4 is the 13. 13 plus 12 is 25. Radius equals square root of 25. Radius equals 5. Now, let us use method B. This is completing the square. I recommend this method because it helps you understand the structure. Step 1. Group x and y terms. Write open bracket x squared minus 6x, close bracket, plus open bracket y squared plus 4, y close bracket equals 12. We moved the minus 12 to the right side, so it became plus 12. Step 2. Complete the square for each group. For x, look at minus 6x. Half of negative 6 is negative 3. Square of negative 3 is 9, so we add 9. For y, look at plus 4y. Half of 4 is 2. Square of 2 is 4, so we add 4. Important, whatever we add to the left side, we must add to the right side to keep the equation balanced. So we write open bracket x squared minus 6x plus 9, close bracket plus open bracket y squared plus 4y plus 4 close bracket equals 12 plus 9 plus 4. Step 3. Simplify. The first bracket becomes open bracket x minus 3 close bracket squared. The second bracket becomes open bracket y plus 2 close bracket squared. The right side, 12 plus 9 is 21, 21 plus 4 is 25. So we have open bracket x minus 3 close bracket squared plus open bracket y plus 2 close bracket squared equals 25. Step 4. Identify center in radius. Now it is in standard form. Center is open bracket 3, comma negative 2 close bracket. Radius is square root of 25, which is 5. Both methods give the same answer. Completing the square is very useful. Now, let us move to section 5. Intersection of a line and a circle. When a line meets a circle, there are 3 possibilities. Possibility 1, 2 points. The line cuts through the circle. We call this a secant. Possibility 2, 1 point. The line just touches the circle. We call this a tangent. Possibility 3. No points, the line misses the circle completely. How do we know which one it is? We use the discriminant. Here's the method. Step 1. Make y or x the subject of the line equation. Step 2. Substitute this into the circle equation. Step 3. You will get a quadratic equation in the form ax squared plus bx plus c equals 0. Step 4. Calculate the discriminant. Delta equals b squared minus 4ac. Here is what the discriminant tells us. If delta is greater than 0, there are 2 distinct points. It is a secant. If delta equals 0, there is exactly 1 point. It is a tangent. If delta is less than 0, there is no intersection. Let us look at example 4. Line and circle intersection. Determine the relationship between the line y equals x plus 1 and the circle x squared plus y squared equals 25. Step 1. Substitute y equals x plus 1 into the circle equation. The circle equation is x squared plus y squared equals 25. Replace y with open bracket, x plus 1 close bracket. So we get x squared plus open bracket, x plus 1 close bracket squared equals 25. Step 2. Expand and simplify. Open bracket x plus 1 close bracket squared is x squared plus 2x plus 1. So we have x squared plus 2x plus 1 equals 25. Combine like terms. X squared plus x squared is 2x squared. So 2x squared plus 2x plus 1 equals 25. Subtract 25 from both sides to make it equal 0. 2x squared plus 2x plus 1 minus 25 equals 0. 1 minus 25 is negative 24. So 2x squared plus 2x minus 24 equals 0. We can simplify this by dividing everything by 2. X squared plus x minus 12 equals 0. Step 3. Calculate discriminant delta. Our equation is x squared plus x minus 12 equals 0. So a equals 1, b equals 1, c equals negative 12. Delta equals b squared minus 4ac. Delta equals 1 squared minus 4 times 1 times negative 12. 1 squared is 1. 4 times 1 times negative 12 is negative 48. So delta equals 1 minus negative 48. Minus negative becomes plus. Delta equals 1 plus 48. Delta equals 49. Step 4. Interpret. Delta is 49. This is greater than 0. Since delta is greater than 0, there are two distinct points of intersection. Answer: the line is a secant. This method is very powerful. It tells you about the intersection without even finding the points. Now, let us move to section 6. Equation of a tangent. A tangent is a line that touches the circle at exactly one point. There is a key property you must know. The tangent is perpendicular to the radius at the point of contact. This means if you draw a line from the center to the point where the tangent touches, that line is the radius. The angle between the radius and the tangent is 90 degrees. Here is the method to find the tangent equation. Given a circle with center C and a point of contact P. Step 1. Find the gradient of the radius. This is the line joining C to P. Step 2. Find the gradient of the tangent. Since they are perpendicular, the gradient of the tangent is the negative reciprocal of the radius gradient. That means m tangent equals negative 1 divided by m radius. Step 3. Use the point slope form y minus y1 equals m times open bracket x minus x1 close bracket with point P. Let us look at example 5. Equation of tangent. Find the equation of the tangent to the circle x squared plus y squared equals 25 at the point P, open bracket, 3, 4 close bracket. Step 1. Identify center C. The equation is x squared plus y squared equals 25. This is the special case where the center is the origin. So center C is open bracket 0, 0 close bracket. Step 2, find gradient of radius CP. C is 0, 0. P is 3, 4. Gradient m radius equals open bracket y2 minus y1. Close bracket divided by open bracket x2 minus x1 close bracket. M radius equals open bracket 4 minus 0. Close bracket divided by open bracket 3 minus 0 close bracket. Man, radius equals 4 divided by 3. Step 3. Find gradients of tangent. M. Tangent equals negative 1 divided by m radius. M. Tangent equals negative 1 divided by 4/3. This is the same as negative 3/4. So, m. Tangent equals negative 3/4. Step 4. Find equation using point P open bracket 3, 4 close bracket. Use y minus y1 equals m times open bracket x minus x1 close bracket. Y minus 4 equals negative 3/4 times open bracket x minus 3 close bracket. To remove the fraction, multiply the whole equation by 4. 4 times open bracket wiki, y minus 4 close bracket equals negative 3 times open bracket x minus 3 close bracket. Expand. 4y minus 16 equals negative 3x plus 9. We usually write the equation in general form with x and y on one side. Add 3x to both sides. Subtract 9 from both sides. 3x plus 4y minus 16 minus 9 equals 0. Minus 16 minus 9 is minus 25. So 3x plus 4y minus 25 equals 0. Answer: 3x plus 4y minus 25 equals 0. This is a classic exam question. Remember the perpendicular rule. Now let's move to section 7, properties of chords. A chord is a line segment joining 2 points on the circle. There is a very useful property. The perpendicular bisector of any chord passes through the center of the circle. This means if you find the midpoint of a chord and draw a line perpendicular to it, that line will go through the center. Let us look at example 6. Finding center using chord. A chord joins points A open bracket 2 comma 2 close bracket and B open bracket 6 comma 2 close bracket on a circle. The center lies on the line x equals 4. Verify this property. Step 1. Find midpoint of chord AB. Midpoint M equals open bracket x1 plus x2 close bracket divided by 2 comma open bracket y1 plus y2 close bracket divided by 2 close bracket. X coordinates are 2 and 6. 2 plus 6 is 8. 8 divided by 2 is 4. Coordinates are 2 and 2. 2 plus 2 is 4. 4 divided by 2 is 2. So midpoint M is open bracket 4 comma 2 close bracket. Step 2. Find gradient of chord AB. Gradient M equals open bracket 2 minus 2 close bracket divided by open bracket 6 minus 2 close bracket. 2 minus 2 is 0. So the gradient is 0. This means the chord is a horizontal line. Step 3. Find gradient of perpendicular bisector. The chord is horizontal. The perpendicular line must be vertical. A vertical line has an undefined gradient. The equation of a vertical line passing through the midpoint open bracket 4 comma 2 close bracket is x equals 4. Conclusion: the perpendicular bisector is the line x equals 4. Since the center must lie on the perpendicular bisector, the center must lie on the line x equals 4. This verifies the property. This property helps us find the center if we don't know it. Now, I want to warn you about common mistakes students make. Section 8, mistake number 1. Sign errors in center. Writing center as open bracket a comma b close bracket from open bracket x minus a close bracket squared instead of checking signs. Remember, open bracket x plus 3 close bracket squared means x equals negative 3. The sign flips. Mistake number 2. Radius squared. Forgetting to square root r squared to find r. If the equation equals 25, radius is 5, not 25. Mistake number 3, general form coefficients. Using coefficients of x and y directly as g and f instead of dividing by 2 first. Remember, the form is 2gx, so you must divide the x coefficient by 2 to get an g. Mistake number 4, tangent gradient. Using the same gradient as the radius instead of the negative reciprocal. Remember, tangent is perpendicular. Flip and change sign. Mistake number 5, discriminant. Confusing delta equals 0, which is tangent, with delta greater than 0, which is intercept. Delta equals 0 means 1 point. Delta greater than 0 means 2 points. Mistake, non-unit, first 6. Non-unit coefficients. Applying general form formulas to 2x squared plus 2y squared without dividing by 2 first. Always make sure x squared and y squared have coefficient 1. before using formulas. Now it is time for class evaluation, section 9. I want you to pause the video and solve these in your notebook. Question 1. State the center and radius of open bracket x plus 1 close bracket squared plus open bracket y minus 3 close bracket squared equals 16. Question 2. Convert x squared plus y squared plus 4x minus 6y equals 0 to standard form. Question 3. Find the discriminant when substituting y equals 2x into x squared plus y squared equals 5. Question 4. Find the gradient of the tangent to x squared plus y squared equals 10 at open bracket 3, 1 close bracket. Question 5. Does the point open bracket 1, 1 close bracket lie inside, outside, or on the circle x squared plus y squared equals 4? Take your time. Write down your steps. Do not rush. I will wait for you. For your assignment, section 10, please do these at home. Question 1. Find the equation of the circle with center open bracket 2, -3, close bracket passing through the point open bracket 5, 1 close bracket. Question 2. Determine the value of k for which the line y equals x plus k is a tangent to the circle x squared plus y squared equals 8. Hint, set delta equals 0. Question 3. Find the coordinates of the points where the line y equals x plus 1 intersects the circle x squared plus y squared equals 25. Question 4. Given the circle x squared plus y squared minus 10x plus 4, y plus 20 equals 0. Find the length of the diameter. Question 5 is a challenge. Find the equation of the circle passing through points open bracket 0, 0 close bracket open bracket 4, 0 close bracket and open bracket 0, 3 close bracket. Let us do a summary of what we learned today. Section 11. Standard form is open bracket x minus a close bracket squared plus open bracket y minus b close bracket squared equals r squared. Center is open bracket a comma b close bracket. Radius is r. General form is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Center is open bracket negative g comma negative f close bracket. Radius is square root of open bracket g squared plus f squared minus c close bracket. Intersection. Substitute line in the circle. Use discriminant delta. If delta greater than 0, 2 points. If delta equals 0, tangent, 1 point. If delta less than 0, no intersection, tangent, perpendicular to radius. Gradient product is -1. Chords. Perpendicular bisector of a chord passes through the center. Check Socran's efficients. Ensure x squared and y squared have coefficient 1 before, using formulas. I know this was a long lesson, but you have done amazingly well. Coordinate geometry with circles can be confusing because of the many forms and properties, but you now have the tools to handle them. Remember, practice is the key. The more you practice finding centers and radii, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there is a specific problem you are stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.